Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Our group will present about queue data structure that is implemented using pointers. My name is Nisa Habiba. My metric number is 1918172. I will explain about the listing. The first topic is listing. Queue can be implemented using pointer by singly or doubly linked list. So to make it clearer, I will explain by this board. As we know, queue in the real life will look like this. So there are some people lining up to the ticket counter. So if we can see, Andy is in the place number 1, Jason in place 2, Lisa in place 3, and Zen in place 4. So when Karen wants to go to the line, she must placed on the last position, which is after Zen. Like this. And she will be on the 5th place. Alright. When the ticket counter sells 1 ticket, so it will erase the person in the place number 1, which is Andy. And the next person will go to the first place. Lisa will go to the 2nd place. Zen will go to the 3rd place. And Karen will go to the 4th place. We can define Jason now as the front node and Karen as the rear or the last node. The next, we will go to the difference of singly linked list and doubly linked list. As we can see, singly linked list look like this and doubly linked list look like this. In singly linked list, each of the element contain the data and the address of the next element. So the first element, the data is 48 and it has the address of the next element, which is 1004, while they are placed in the address 1001. Same like that, the next one, the data is 35 and it has the data of the address for the next element, which is 1008, the address of the next element, and they are placed on address 1004. Different with doubly linked list, each one of the element has one data and two address, which is defined the previous address and the next address. Like the first element, the data is 48 and the previous address is null since it is the front, and it also has the address of the next element, which is 1004, while these elements are on the place of address 1001. And we can see on the last, it is also has the address of previous element, which is 1012, and the data is 34, and it also has the address of the next one, which is null because it is the rear, and they are on the place of address 1014. Previously, we have seen the difference between singly linked list and doubly linked list in the graphic. Now we see the implementation on the code. So this one for the singly linked list, we can see here the pointer only point to the next address. Okay, we have defined the data. The first one is 48 and then 35, 72, 19 and 34. And for the nodes, the first element will have the address of the second address, which is 2, and the second element will have the address of the next element, which is 3, and so on. And if we execute, it will show like this. The number is 48, 35, 72, 19, and 34. We go to the next code, which is the doubly linked list. Here we can see the difference. If the singly linked list only have the node for the next address, now we have the previous address also. Okay, when we have defined the data 48, 35, 72, 19, and 34, after that we will have the connection of the nodes. So the element 1 will have the address for the next element, which is 2, and we'll have the address for the previous one, which is null. And for element 2 also like that, we have the address for the next, which is 3, and we have the previous address, which is 1, and so on. We will try to execute. Okay, it is exactly the same because we define the same data 48, 35, 72, 19, and 34. So that's all about the listing or displaying the queue using pointers. I will pass to the next presenter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rafi Taufiqul and I will be discussing about enqueuing or insert operation on a singly linked list and the doubly linked list. So the first one on the singly linked list, the insert operation append the queue by adding an element to the end of the queue. So an insertion on the singly linked list can only happen on the rear end of the queue. So it cannot happen on the front side of the queue because on the singly linked list it actually implements the first in first out rule. So the first number that comes in on the address or on the queue, it will be the first node that will be thrown out if we were to have a dequeue operation. And then the new element will be inserted on the last queue on the inside the queue. So there is two scenarios in which the insertion operation can happen inside a singly linked list. The first one is the insertion inside an empty queue, and the second one is the insertion made in a queue which have an element. So the first thing that we will discuss is the insertion with an empty queue. So inside the code we will establish a struct which we will name node, and inside the node it will contain the data type integer and data, and it will also contain the struct node pointer which we will name next. So this next variable will contain the next node inside the queue. So I will discuss it in detail later. So the first thing is inside the singly linked list we will establish a front and a rear. In this one, front which have a null address and the rear which will have a null address as well. Because a singly linked list has a time complexity of 1, if we have the rear here, so it will not go through the entire queue in order for us to display or insert an element. Because we have this rear operation here, it will only has a time complexity of 1. So, and then now we will establish the void in queue or function in queue, which will contain the integer x, which will be the actual data in which we will have the node contain or hold the data for. So the first is we will make a new node in which it will has a malloc function. The malloc function is a function for dynamic memory allocation, and this malloc function can be called if we have the cstd library included inside the C++ programming. So this malloc function will actually make a void pointer which will be allocated into the new node. So the new node right here, because we want to make a new node inside this empty node, we will make enqueue operation which will contain the data 20. So we have this one 20, the actual data, and the pointer or the void pointer made by the malloc, it's 100. So 100 is the address of the data 20, and then the front and the rear will be pointing at the new node because we have the if statement here. on the if statement, we have the front equals to null and rear equals to null, which is true because we don't have any data inside the queue. And then inside the if statement, we will establish that front and rear will contain the pointer of the new node of 100. So after we establish the value of the pointer of in front and rear is 100 and 100, so the front will point at the new node of the data 20, and the rear will also point at the same node. And then next we will be discussing on the insertion with the field queue. So we will be continuing on the same code. So after we if we want to enqueue another node, we will go into this enqueue function again, which will hold the data 16, and the data 16, it will make a void pointer of 210. So this data 16 will have a pointer of 210. So after we go back into the if statement right here, we know that the front actually is not equals to 0 because it contains the latest node of 100, and the rear also contains the latest pointer of 100. We will go to the else statement, in which we will refer to the rear node. The rear node is the latest node that is inside the queue. So this one is inside the queue, and this one is not inside the queue yet. So on the rear node, we go to the next. The next is the next pointer, which is the null pointer right here, because it does not point to any new node yet. And then we will change the value of 0 into the new node. The new node, which is 210. After we change it to 210, this rear node will point at the latest node that we input into the queue. After it points into the queue, we want to change the rear function into or the rear pointer into 210 as well, because the singly linked list have the time complexity of 1. It does not have to go through the entire queue if we want to insert a new number. We just have to refer into the rear pointer, because it will always hold the pointer of the latest number. We won't have to go through the whole queue, and thus we will not waste memory or space. And then after we change the rear to new node, everything will point at the latest node. Next, we will be discussing on the insertion or enqueuing in a doubly linked list. So in a doubly linked list, it contains 3 chambers inside the node. The far left or the front part contains the previous node, and the middle part contains the actual data inside the node, and the back part will contain the next node. So in this particular linked list, we can traverse forward by using the next field or the rear part, and we can traverse backward by using the front. The front is on the left, the rear is on the right. So we can traverse backwards or forwards in a doubly linked list. So we will be discussing on enqueuing on the front side of the linked list, or on the doubly linked list, and we will be discussing enqueuing on the rear end. So the first one, we will establish that there is a queue already, because we want to enqueue. There is a queue of 10, node of 10, node of 30, node of 22, which with address 100, 200, 250, and the rest of them will contain the next pointer of the next node and the previous pointer on the last node. So it will contain the next pointer of 200, it contains the pointer of 100, it contains the pointer of 250, which is the next one, and the latest one will contain the node pointer of 200, which is the previous one. And then we will have the head pointer, which contains the pointer of the first one, and tail, which contains the pointer of the last node. So in this function again, we will have almost similar function. We have the structure node, in which it has the data, the actual data, like 10, 30, and 22, the actual data. And then we have the struct node next. So if you realize on the singly linked list, we only have structure node pointer to the next, which in this doubly linked list, because we want to traverse backwards and forwards, we will have the previous node as well, so that one node can actually have 2 pointers, one points backwards and one points forwards. And then we will also initialize the head and the tail pointer, which is this one. This is the head pointer, this is the tail pointer. So after that, we will establish a function. We will name it void insert back, which means insert beginning. We will make it is the same as singly linked list. We will make a new node with the malloc function, which will create a void pointer into the new node. In this particular example, the void pointer will contain the pointer 300, and then the data will be 7, because on the next line we will prompt the user to input the data, and then after that the data, which will be contained inside the data part or the middle part. On this new node, there is a null pointer on the rear and null pointer on the front side of the node. And then next we will head to the head. The head is this one. The head is the first node inside the queue, and the previous one, and then we will go into the previous chamber. So the previous chamber is on the left side. So inside the head node, on the previous pointer, which is 0, we want to change the 0 to contain the new node, or the new node pointer. The new node pointer is 300. If we change this one to 300, then this previous pointer of the head will avert itself to point towards the new node. After it points into the new node, we want to go to the new node, this one right here, and then on the next pointer, which is still 0, we will want to refer it into the head. So this one, this head right here, has the value address of 100. So this 100 will point into the head address, and then this previous head address will point the previous pointer will point into the new node. So we see right here it changed to 300 because we have this head previous equals new node 300, and this will be equals 100 right here. And then we want to change the head into the new node because it is the new head inside the W linked list. And after that, we can see that it has, if we want to tidy this up, it will look like this. So the head will contain the new pointer, which is the new node, and then the new node will contain the next data, or the previous head point, the previous head node, which is now the second inside the queue. Next, we will be discussing on the insertion at the end in a doubly linked list. So in a doubly linked list, it has the same order of code, and the only difference is that we name the function as insert end. So we want to insert at the end of the queue. This is all the same. We prompt the user to insert data, and then the malloc will create a void pointer which will hold the new node of data 22. And then on the tail end, we look to the next. So the tail which is this one, the tail, and the next pointer, which right now still contains a null pointer, we will want to change the 0 into the new node. So the new node of the tail pointer will contain the pointer of this one, 400. We will change this one to 400, and then on the new node right here, we will want to change the previous pointer from 0 to the same as the tail. The tail has the address of 250, so 0 will contain the address 250. After that, this new node will point at the tail of the queue, and then the tail of the queue will point into the new node. After that, if we were to tidy this up, we will also want to change the tail value into the new node. So after the tail value contains the pointer of the new node, it will look like this. So this tail, which will contain the value of the new node pointer, and then this new node will be the last inside the queue. So that is how we actually insert the value and the doubly linked list from the rear end. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Salsabila, and I'm going to explain about the dequeuing process of the linked list. As mentioned before, that enqueuing is the insertion of the new element that happened in the rear of the queue, while dequeuing is the opposite of that. Dequeuing is the deletion of the first element that performed at the other end of enqueuing, which is in the front side. This operation removes the front node and moves to the next node to fill the front. This is the example of dequeuing process. So we have 4 nodes, which is the 60, 86, 74, and 43, and we have 60 as the front and we have 43 as the rear. If we dequeue these nodes, we remove the 60 and we made the 86 become the front. As mentioned by Sister Nisa Habiba, linked list is singly linked list and doubly linked list. This is the example of singly linked list, where the dequeuing process is only happen in the front element. This is the code that represents dequeuing in singly linked list. We start the code with void function. If the queue is empty, we return null. If the queue is not empty, we copy the front to the time variable and we move front one node ahead. If the front becomes null, then change rear also as null. This means that the queue is only have one node, so we change the rear to the null. If not, we delete the time variable, which is the previous front before. And then we move to dequeuing in doubly linked list. In doubly linked list, dequeuing or deletion can be performed in the front and the rear. So this is the original queue. If we dequeue the front, which is we remove the 60, we make the 86 become the front. So this is after dequeuing the front end element. And if we dequeue the rear end element, we remove the 43 and we make the 78 become the rear. This is the code that represents dequeuing the front element. So we start with the void function, and if the queue is empty, then under flow condition, state here that we see out the underflow. If the queue is not empty, we copy the front to the time variable and then we make the front to the nodes next to it. If there is only one element, if only one element was represented, we make the also a null. If not, we make the previous front to the null, and then we free the time variable, and then we decrement count of elements by 1. And this is the dequeuing process of the rear element. If the dequeue is empty, then underflow condition, which is we output the underflow, and if not, we copy the rear node to the time variable and we make the rear to the previous node of the rear. If only one element was represented, we make the front as a null. If not, we make the next rear to the null, and then we free the time variable, and then we decrement the size of element by 1. This is all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muammar Rafi Ghozi Masdar. My metric number is 1927535. And this is the implementation of queues using pointers. Okay. A queue is a linear data structure that supports FIFO operation. And linear means that you can add or remove items sequentially from the queue. And FIFO means first in, first out, which means that the item that you queued first will be removed from the first queue. For example, this is a linked list with 4 elements. To implement queue using linked list, we need to make a linked list where an element can be only added from the rear end and can only be deleted from the front end. For example, this linked list contains four elements, which are 5, 10, 15, and 20. If we want to add a new node, the new node will appear on the rear end. And if we want to remove a node, it will always be the most front node that will be removed. Okay, so now for insertion. If we add a new node, the last node will always have the null address since they don't have another address to refer to, whereas the node after the newest node will be linked to the newest node address. And for deletion or removal, like we have talked before, it will delete the most front node and will make the second node as the first node. And then for display, in this shortcode, P will be valued as front for entry point of the linked list. Then while P is not equal to null, then the program will continue to print the info from each node, where in this example the infos are in the first node is 10, the second node is 15, and the third node is 20. Each time the program loops the while program, the program will also move the P each time to the next node, where P link contains the address of the next node except for the last node, which contains null. So when P reaches the last node, P link will be valued as null, and null will be continued to P. Then the while loop will execute again, but it will be valued as false because P is equals to null. Therefore, the program will exit the loop.